This is an explanation on how to do the model for the hand warmer project. So we are showing the dissociation of salts, and we modeled something similar to that earlier. So we had water, and let's say that this is a salt. We have a cation and an anion. The water comes and it breaks apart the cation and anion through the interactions. And so we're going to show that process. So I'll take the example sodium sulfate. Sodium sulfate. Now, first, let me show the equation for this dissociation. So sodium is, we have two sodiums, and then we have one sulfate, which is polyatomic. And so the sodium sulfate dissociates, and it's solid before it dissociates, into sodium. Now, how many sodiums are there? Well, there's two. So we put a 2 there, plus sulfate. Now the sodium forms a 1 charge, the sulfate forms a 2 minus charge, and these are both aqueous. Now, how did I know that sulfate stayed as a group this way? Some people try to separate the sulfate into sulfur and 4 oxygens. Well, sulfate is polyatomic. It covalently bonds in a structure similar to this, so it stays stuck together. And since it stays stuck together, we are going to treat it that way as it dissolves in water. So this process you will represent with a physical model, and you'll need to pick different colors to represent the different ions. So let's say I have the red representing the sodium, and the blue then represents the sulfate. Now, since sulfate stays together as a group, it's okay to just use one color to represent that because it's one ion, although it has several different atoms within it. So when we show this process taking place, first we have the sodium sulfate together. We have 2 sodiums and 1 sulfate as a whole. So I'm going to represent that with 2 reds with 1 blue. And as it reacts with water, or it is put into water, I guess water itself is not actually a reactant or product in this process. It's not even technically a chemical reaction, but it's put into water, and so then the sodium separates from the sulfate. So we had 2 sodiums. We show that now separated, and the sulfate I can show then separate as well. Now, what's causing it to separate? Well, it's water. So the water interacts with the sodium and the sulfate ions. So let's say, for instance, and I need to add a key for this as well, the red represents the oxygen of water. So this represents oxygen, and then the black represents the hydrogen of water. So given that we have water represented by these small beads, if the sodium is positively charged, what part of water would be attracted to that? So we'll need to show some water molecules there, indicating the right kind of attraction to them. So we know that opposites attract. The negative oxygen is attracted to the positive ion. And then we would add a few more of these water molecules to show how each ion gets surrounded. The sulfate is a negative charge, so here we're going to have an opposite relationship. Where the positive hydrogen is attracted to the negative sulfate ion. And we would do that for each one. And add a few more water molecules around it to show how it gets held in place by the water molecules. So I'm not going to finish this, but you would want to just keep adding a few more water molecules around each ion to show how it gets held in place. Are there any water molecules on this other side? No, remember this was before we added water, so we don't need to show any water molecules over here in the model on the reactant side. So we do the physical model as is shown here, and then there's one more thing that we need to do. We need to show the energy change. So the energy change, using your calculations, so you calculated the molar enthalpy of the reaction. That was this part right here. Now this was not a salt that we did, of course, so the enthalpy of this process, the heat of the solution, is 2.1 joules per mole. So that energy, since it's a positive sign, it means that the energy is going into this process, or we could say it's an endothermic process. So we have the reactants starting at this energy level. If they started at this level, and we have to think, if energy is going in to the bonds and the interactions, is that going to increase or decrease? Now we're thinking of potential energy. So in other words, the stored energy, not the energy that's being released to the water, but the energy that's being stored. So in this case, if the energy is going in, we would draw the products at a slightly higher energy level. Let me make a little space here. Move this out of the way. And so as a result, I have my products. Now, this process would need some activation energy in order for it to get started. So we illustrate that activation energy with sort of a hump here. Energy has to be put in. And so this illustrates the progress of the reaction, or the energy change as the reaction occurs. Now you can think about what would happen if this was an exothermic reaction as well. So if we had a negative sign here, which one would have higher energy, the reactants or products? So this is the layout of the model, or the basic idea. Keep in mind that it's going to be different based on which salt you're using. So this is what it would look like if it was sodium sulfate, but each unique salt is going to look a little bit different. So you'll need to consider your specific case, your specific salt, and then of course once this is all placed, all the beads are in place, then use some tacky glue and just glue everything in place. Then you can glue the entire model onto your poster board.